Today's problem, count unique vowel strings. Let's see, am I able to pull that over? Yeah, okay. Yeah, let's just look at the problem first. You're given a lowercase string, s. Determine the total number of distinct strings that can be formed using the following rules. Identify all unique vowels present in the string. For each distinct vowel, choose exactly one of its occurrences from S. If a vowel occurs multiple times, each occurrence represents a unique selection choice. Generate all possible permutations of the selected vowels. Each unique arrangement counts as a distinct string. That isn't the best explanation that I've ever heard. Okay, well, yeah, okay, well, let's take a look at this. Here's a string, A, E, I, O, U. So they use the word permutations, right? Okay, permutations. So we have five things here, five vowels, and we want to know how many permutations can we make. Well, the way you figure out permutations is just by doing factorial. So 5 factorial is 5 times 4 is 20 times 3, 60 times 2, 120. This one, we have 2 vowels. Well, 2 factorial is 2 times 1 is 2. This one, we have an A and an I. We have an A and an I, so that's 2 vowels. It's 2 factorial, but we have 2 choices for the A, so we have to also multiply times the number of choices. Actually, it would be easier to kind of show how this works. Here, let's take a look at this. Expected complexity, O of n, topic tag, combinatorial, mathematical. All right, let's do this. Let's do custom input. Why is it, I would like to see it kind of come up with a better custom input than that. Let's do this first then. Let's just do a quick sanity check on that. Okay, so that works. Here's the AEIOU. AEIOU 120. All right, good. Custom input. What if we had another U? All right. So what's going to happen here? We'll get the 5 factorial, but we have a choice. You know, in each permutation, we have a choice of 2 U's. So really, we're going to be able to create twice as many permutations. So that would be 240, right? Let's get the expected output on that. Okay, 240. Well, what if we had 3? We had 3 U's. Why am I not able to? Oh, I see. Custom input. Right. What if we had 3? Well, again, we're using unique. Unique vowels, distinct vowels, meaning we've only got 5 unique vowels, so the permutations are going to have a length of 5. So that is the 5 factorial, but in this case we have 3 U's, so each permutation we have a choice of which of the 3 U's to use. Given that we have 3 choices for one of the letters, we're going to be able to have 3 times as many permutations. That would be 360, right? 120, but we have 3 choices, so that's 360. All right, let's try one more. Let's say we have 2 U's, but we also have 2 A's. All right. Well, again, we have 5 distinct vowels. But we have two choices for the A. We have two choices for the U. So we have to multiply times the number of choices. So we have the 5 factorial, 120, times these two choices, so that's 240, times these two choices, so that should be 480, right? Let's try it. Expected output is 480. Okay, so that being said, let's take a look at the implementation. All right. Here's our vowels, A, E, I, O, U. We have a map. It's going to hold characters and count. And for the length of the string, we'll look at each character. If that character is a vowel, we are going to put it in the map. If it's not, we're going to put it in the map with a count of 1. If it's not already in the map, if it is in the map, we'll increment the count. All right, once we've gone through the entire string, we'll look at the map. Is it empty? If it is empty, we return 0. It's an edge case. Otherwise, choices. Choices. We looked at examples of the choices. What if we had 2 U's? What if we had, or what if we had 2 choices for the letter U? What if we had 3 choices for the letter U? What if we had 2 choices for A, 2 choices for U? So we need to know how many choices we have if it is greater than 1. So for each character in the map, we're going to get the value as the count or the choices, if you want to think of it that way. Result equals, choices. Wait. I'm sorry. We're going to go through the map and initialize choices to 1 and then multiply times the count of each vowel. So if there are any vowels that occur more than once, we're going to get our multiple choices. For example, if there's 1 A, E, I, O, and 3 U's, we'll get a 3. If there's 2 A's and 2 U's, we'll get a 4. But in any case, we'll get our number of choices here, and the choices, as we saw with the expected outputs, the result is going to be the number of choices times the factorial of the map size. How many distinct letters do we have? Now, we've got a factorial function here just to simplify things, keep it clean. But all this does is take in a number and multiply everything from 1 to that number and return it. All right, let's scoot this over, see how it works. Well, not that many test cases. I guess was there a limit on oh, I see, it only goes up to, but the size is only up to 100. Okay. So that's it. Factorial times choices, and please like the video, subscribe. I'll send you problems of the day right into your inbox, and we'll see you next time.